Hello, welcome to the last video we'll be doing here for chapter 6. We're moving on to number 22 here. So number 22, there's definitely a lot more going on. We're playing into a lot of things that we've already previously learned. And let's get started with it. So we have a score on a test of a mean of 70. So we're going to kind of write that off to the side. So our mean is equal to 70. And we have a Q3 is 81. So if you remember Q3 from our box plots, so Q3 is kind of like the 75th percentile, right? I'm just going to kind of write that out there, 0.75, and that is a value of 83. The scores have a distribution that is approximately normal. We want to find the 90th percentile, or what is the value of x at the 90th percentile here. So we're given everything but a standard deviation, but we're given quite a lot. If we were to take our z times our standard deviation plus our mean equals x and rearrange that formula to solve for our standard deviation, standard deviation is going to equal x minus mu divided by z. Well, we're given an x value of 83, right? Minus a mu of 70. But what's the z value? Well, the z value is where this comes into play. So we want to find the z of the 75th percentile, because we know that that is the z value of 83 of x, and when we solve that out, we'll be able to find the standard deviation to it. So the z of 0.75 is 0.67 z value. When we solve this out, we'll get 19.402, and that is now our standard deviation. So now that we have a standard deviation, and we want to find a value of x at the 90th percentile, if you scroll up to the other parts of the video, I believe just above this one, right? At the 90th percentile, we already know that that value is going to be 1.28. So we have x times 1.28 times our standard deviation that we just solved for, 19.402, plus our mean of 70, will now give us the value at the 90th percentile, or the x that you need at the 90th percentile, which would be 94.83, or answer D. So this one is great because it's taking in a lot of what we learned and kind of applying it going forward. Number 23. After reading it all and going through, you can kind of pretty much break this one down to be the mean is 0 and the standard deviation is 1, where the values of the mean and standard deviation are all test scores are standardized compared to z-score. If we have, when we're converting all of them, a mean is always 0, standard deviation is always going to be 1 when it's converted, or using the mean normal distribution. This one, still didn't change it. We don't want to say less than, change it to greater than. If sample size is greater than blank, the sample size must come from a population having a normal distribution, in order to follow normal distribution calculations. And this is just 30. Many people will kind of debate this, right? If you want to get into hot topics, what is the sample size between saying it comes from a normal distribution versus non-normal distribution, and looking at all these things, and where most people kind of agree is about 30, and that's where our book goes and uses, so we will be using it as well. As the number, of course, you always want more people in a sample size. The more and more you have, the more accurate your information is going to be. But we kind of have this 30 as this kind of magical number cutoff. Some people might say 40, some people say up to 100. Every person is going to be kind of a little different, but we will always stay consistent with the book, and our book says it's 30, so we will be going and using that. Moving on to number 25, we want to assume red blood cell counts of women are normally distributed, but now we have a new mean, and we have a standard deviation. Now we want to find the 80th percentile for the red blood cell counts of women. So let's write what we know off to the side here. Mu is equal to 4.577, the standard deviation of 0.382. And we want to find the 80th percentile, or the x value at the 80th percentile, right? So x is going to equal the z of 0.80, the 80th percentile, times our standard deviation. Oh, there's a 2 there too. Plus our mean of 4.577, When we go to our book, find the 80th percentile, we'll see that our z value is 0.84. So we write all this out again. I'm also truly apologetic that I have terrible handwriting, so hopefully me talking out helps out. When you solve all this out, you'll find that it's the value of 4.8978 million cells per microliter. When we write all this out, we'll find that our value is B. That concludes our video here. Once again, we're using the same formula, and we can isolate different variables to find other variables if we're given the right information. Always try to write what you have onto the side. Use what you know to help solve for the problem. If you have any questions or concerns, always please drop in anytime. Email me, come to office hours. I'm here to help and make sure you understand. As I've always seen, most people have a very good understanding where people miss things or where points are probably taken off is just kind of just like what I call this fine tuning. You just come in and just fine tune it, because as you start a problem, if you start off going down the wrong path, it's just going to keep the snowball effect is all going and being incorrect. And if you can just fine tune those skills and make sure you're on the right path to begin with and you understand where the problem's going, that certainly increases, the likelihood of getting the maximum amount of points possible. So I am here. Email me, come in, talk with me. If you're online and you need to, and you can't come in, we can always do video sessions or just massive emails back and forth. All right, good luck, and I'll see you all in the next video.